Today, we're going to cover solving systems of equations by using graphs. In this lesson, we'll learn how to plot two linear equations on the same graph, find their intersection, and use it as the solution to the system. By the end of this video, you'll feel confident in using graphs to solve any system of equations by locating their intersection point. So let's get started. When solving systems of equations graphically, we're looking for the solution that makes both equations true at the same time. In a graph, this solution is where the two lines intersect. Start by putting each equation in slope-intercept form, y equals mx plus b, if it's not already. Then, plot each line on the graph based on its slope and y-intercept. Once both lines are plotted, look for the point where they cross. This point of intersection is your solution to the system. There are three possibilities when graphing systems of equations. The first one includes the lines intersecting at a single point, meaning there's one unique solution. The second possibility is when the lines are parallel and never meet, so there's no solution at all, and finally, the third possibility involves the lines overlapping entirely, providing infinitely many solutions. Now that we know what to look for, we're ready to try some examples to see how this works in action. Let's get started. Solve the following system of equations by graphing y equals 2 times x plus 1 and y equals minus x plus 4. First, let's identify the slope and y-intercept of each line. Remember, each equation is in slope-intercept form, y equals m times x plus b, where m is the slope and b is the y-intercept. For the first equation, the slope is m equals 2 and the y-intercept is b equals 1. For the second equation, the slope is m equals minus 1 and the y-intercept is b equals 4. Now, let's plot each line using the slope and y-intercept values. Start by plotting the first line from its y-intercept at the point 0, 1. From this point, use the slope m is equal to 2 to move upward 2 units and 1 unit to the right. For the second line, we can start plotting at the y-intercept, which is at the point 0, 4. From this point, we can use the slope m is equal to minus 1 to move downward 1 unit and 1 unit to the right. With both lines plotted, we can see where they intersect. This point of intersection is the solution to our system of equations because it's the point where both equations are true at the same time. In our case, this is the point 1, 3. So, the solution to the system is the point 1, 3. This means that when x is equal to 1, both equations give the same y value of y equals 3. Let's move on to the second example. Solve the following system of equations by graphing y equals 2 times x plus 1 and y equals 2 times x minus 3. Let's start by identifying the slope and y-intercept of each line. Both equations are already in slope-intercept form. For the first equation, y equals 2 times x plus 1, the slope is m equals 2 and the y-intercept is b equals 1. For the second equation, y equals 2 times x minus 3, the slope is m equals 2 and the y-intercept is b equals minus 3. Notice that both lines have the same slope, which tells us that the lines are parallel. Since they have different y-intercepts, they will not intersect and therefore have no solution. Let's plot both lines using their slopes and y-intercepts, just as we did before. Start by plotting the first line from its y-intercept at the point 0, 1. From this point, use the slope m is equal to 2 to move upward 2 units and 1 unit to the right. Moreover, for the second line we can start plotting at the y-intercept, which is at the point 0, minus 3. From this point, we can use the slope m is equal to 2 to again move upward 2 units and 1 unit to the right. Now that both lines are plotted, we can see that they are parallel and do not intersect. Since there's no point where these lines cross, there's no solution to the system of equations. For a system with no solution, the lines are parallel, meaning that they have the same slope but different y-intercepts, so they never meet. Whenever you see two lines like this, you know there's no solution to the system. Let's move on to the final example. A cell phone company offers two monthly plans. Plan A costs $10 per month plus $0.50 per minute of call time. Plan B costs $5 per month plus $0.75 per minute of call time. Our task is to determine for how many minutes of call time would both plans cost the same. Let's dive in. To find the number of minutes where both plans cost the same, let's set up equations based on the cost structures provided for each plan. Let x represent the number of minutes and y represent the total monthly cost in dollars. So, for Plan A the cost is $10 plus half a dollar per minute. We can write this as y equals 10 plus 0.5. For Plan B, the cost is $5 plus $0.75 per minute. We can write this as y equals 5 plus 0.75. Now, let's graph each equation to see where they intersect. Start by plotting the first line from its y-intercept at the point 0, 10 as the starting fee of $10 for Plan A. From this point, use the slope m is equal to 0.5 to move upward half a unit and 1 unit to the right. Moreover, for the second line we can start plotting at the y-intercept, which is at the point 0, 5, since $5 is the starting fee for Plan B. From this point, we can use the slope m is equal to 0.75 to move upwards 0.75 of a unit and 1 unit to the right. With both lines plotted, we can see where they intersect. This point of intersection is the solution, representing the number of minutes where both plans will cost the same. In our case, this is the point 20, 20. The solution with the point 20, 20 tells us that at 20 minutes of call time, both planes cost the same, $20. So, the correct answer is A, 20 minutes. Let's quickly review what we learned about solving systems of equations graphically. When solving systems of equations graphically, our aim is to find the point where both equations intersect. The intersection represents the solution, making both equations true at the same time. For each equation, plot the line by identifying the slope and y-intercept from the slope-intercept form, y equals mx plus b. Remember, the slope m tells us the rise over the run, and the y-intercept tells us where the line crosses the y-axis. We encountered 3 types of solutions. To start off, when the lines intersect at one point, there is one unique solution. Moreover, when the lines are parallel and do not intersect, there is no solution. And finally, when the lines overlap completely, there are infinitely many solutions. With practice, you'll be able to solve any system of equations by plotting, identifying slopes, and spotting intersections. Keep practicing, and remember, every intersection is the solution you're looking for.